Hello, everybody. Today, I'm going to do a little show and tell of just some different ways of debugging um, a JavaScript application. And as the example, I'm going to be using Lodestar, which is the TypeScript beacon node that we've been writing for the past year. So I guess I'll get started by sharing my screen. Okay, can everyone see me? See the screen? Cool. All right, so I started up some code before the meetup just so that things would be working. Live demos, live coding can be a little sketchy, so I can tell you where we're starting here. On the top of the screen, I have a Lodestar node started, and I started it by cloning down the most recent version of Lodestar from GitHub, building the whole repo, following the instructions, and then I started it by running node -- inspect a Lodestar beacon, and I'm using a testnet protter. So that's what's running up above. I'm not going to start it again, but just to give you a sense of what's going on. The question, like, how do you debug a running JavaScript application? It's right now we have some logs going, and I guess you could print a whole bunch of logs, print a bunch of strings to the screen, but that's not really scalable. And I guess at a certain point, you're just kind of left wondering what actually is going on behind the scenes. So I can kind of see, like, I'm syncing, I guess, 1 slot per second, which, if you know anything about ETH2, that's not very good. 10 peers, I guess, seems a little low, but but there's not very much you can really do here. Not a lot of input that you can really give, not a lot of output really we can change. We could try to hit maybe the API and figure out what's going on there, but I'm going to show some other fun techniques. So one thing that we use, and I think a lot of other applications use, not just JavaScript, but they use Prometheus Metrics and hook it into fancy looking dashboards. And these metrics are a really good way of exposing just things that are happening under the hood, especially certain things in JavaScript that are really nice to know. So here I've got a dashboard, which I've already plugged into this running node. And now we can actually see a lot more. So this is much more rich than just this, line by line, not getting much here. Here we can actually see, we put in some work to actually build a dashboard. So there's a little bit of upfront work, but once you get this going, you can actually begin to maybe see if there's a problem, or see where maybe some hotspots are. We can see the heap space. This is the total. This is the kind of the memory used. Process heap bytes. These are kind of 2 metrics relating to the memory. We can see some metrics relating to the garbage collection. And if you're a JavaScript developer, these are 2 pieces that would be really important to you. Another thing we can see is event loop lag. It's important to keep that lag low. So this gives you kind of one extra level of granularity into a running application. But you can actually, there's other tools you can also use. And we're going to thank Google for this one. I'm going to open up Chrome or Chromium and navigate to Chrome://inspect. And now, if you remember, I started my node process with this -- inspect flag. And what this did was it turned on debugging or it allows Chrome to hook into this running node process. So just by default, I went to Chrome inspect. By default, I've got this little target. It says Lodestar. Hey, this is great. And what I can do here is basically get a Chrome DevTools window, just like you could get on any web page if you right-clicked and went to the right setting. But right now, it's actually running Lodestar. It's actually running the this node process. So we can do some really interesting things. So like one question you might have is like, all right, well, why is our syncing so slow, like 1.5 slots per second? Well, one thing you might be able to do is you can go to the profiler and you can start a CPU profile. So we're just going to be starting this. It's starting on the node. Hopefully the node isn't breaking. Oh, it's still good. But after a while, we can run this for as long as we want. After a while, we can stop it. And this should give us a flame chart. So this flame chart gives us a breakdown of what actually was happening over time. And we can see very quickly that there are certain things that are taking a lot longer of time than other things. So right away, we can immediately see, wow, this process chain segment, that's what's taking a lot of time. And in fact, verify signature sets batch. If we see this happening a lot, so almost all of our this process chain segment, it's almost all verifying signature set batch, whatever that is. In fact, it's BLS signature verification. So it's just a very expensive operation. But doing this, you can really drill down and see what's taking a lot of time, what's not, try to find any hotspots. And this is all happening on this running node. So, as you're doing updates, as you're changing the system, every time you run your application, you can always hook into it and be seeing what the latest hotspots are. Another really great feature, I'm not going to use it right now because there's not enough time, but is doing a heap snapshot. We could take a snapshot. One issue with doing this is that it would freeze the node while you take a snapshot. Nothing else is running. But what you get out of it is it will show you in detail all of the memory usage of the running node. So exactly what's being stored where, what is referencing what, and this is a really great way of finding memory leaks, finding references that are retained that are like they shouldn't actually be there, and you can actually bring any of those references down into the running console and then inspect them, writing JavaScript to go deeper and deeper. You can also look at the source code for anything that's running and add breakpoints and step through any of the running code. It may affect your peering, and as your peers may not like that you're stopping the code, but it's a great feature for stepping through tricky pieces of the code and going line by line and to see if it's running the way you're expecting it to run. So all in all, I don't know if this is an underused tool or just not. In my opinion, I haven't seen that it's used a lot, but I think it's a great way of debugging live JavaScript applications. And it's really definitely helped. It's definitely saved our hide quite a number of times on Lodestar. And that's really it for me for now. If anyone has any questions, we can take them.
Awesome, Cayman. Thank you for the talk. Yeah, I'm not a developer, but yeah, it's just so cool to see like all these different tools and methods for debugging. things. I see Masse has raised his or her hand. You can feel free to unmute yourself and ask your question.
Hello, I just want to say thanks for that really great presentation. This looks like a really cool tool, and I just wanted to ask if if you could use it with like any Node JS application, or if it's just with like is it just with things that are like that are only for like blockchain, or if it could be used with anything.
Yeah, good question. So this whole Chrome DevTools can be used with any Node application. You would just need to make sure that whenever you're running it, you have to be sure that Node is being called with this inspect flag. Otherwise you're not gonna be able to hook into the application. But yeah, it can work with any Node application. The metrics, that would be something that the application would have to implement themselves kind of ahead of time. So that may or may not be available.
Cool. Thank you so much.
Awesome. We also have a question from Dap Lion.
Go for it, Lion.
Hey all, thanks for the talk. Good to see you all. Hey, looking at this PLS thing that it's very slow, do you think it will be a good idea to put it on a worker thread, like maybe?
Absolutely. This is kind of maybe a trick question, but this is something we're working on actively right now. Yeah, BLS is a great candidate for being put on a thread because we could break up this work, and it's not necessarily sequential. We can break it up and throw it off to these different web workers, and hopefully cut down a lot of like that time could be maybe cut in half, and that would make our sync speed faster. But that's definitely something that you only know by actually looking at the hard data, or like looking at something like a flame chart.